Well, hi, good morning. Thank you so much for joining me here in my shop. It's June 3rd, and just a little bit of news. Hopefully the image you're seeing, if you've watched lots of my videos, the image you're seeing looks clearer and sharper than it's ever looked. So I have a new camera I'm using, the one you're looking through right now, and it's an inexpensive camera, promised a better picture. Goodness knows I've bought a dozen cameras in the past under that kind of promise, and they never ever have a better image than the ones I was using, but this one seems to. So hopefully that'll help make these videos much better. We'll see how it goes. Number two, I haven't mentioned it, but there's a lot of forest fires burning in Canada right now. It's producing a lot of smoke into the atmosphere, including here. Last night my wife and I were outside trying to see the aurora, which wasn't there, and there were some clouds in the sky too, but we could smell the smoke. You could just stand outside and smell smoke. Now, these fires are burning 1,000 miles away or farther, and the problem is it's made the sky go smoky, I guess what you would say. So astronomy going down the drain for the summer already, and these fires, and I'm complaining about the smoke, these fires are displacing thousands of Canadians who have to leave their homes, often for extended periods, months in fact, while these fires rage around their town, or once in a while right through the town and just burn the whole thing down. So it's a scary time for all those people, and they don't just go 20 miles down the road. They go to a totally different part of Canada where they live temporarily for an extended period. It's really terrible stuff. Climate change. There's always been forest fires. I certainly heard about them all my life. It sure seems like it's much worse now. It seems that way. I don't know. Okay, enough on that. What are we going to do with the radio today? So today I'm under pressure for time, actually a lot of pressure. So I'm going to go after these two capacitors here. We're going to figure out what they are. I'm going to use my new information to figure out what they are, so there won't be so much doubt around it. Shame on me for not availing myself of this information earlier, but you know, hey, I'm lazy. Let's take a look at it. Okay, I misspoke. It's not from Pacific TV, it's from Nostalgia Air. That's a website I tend to forget about all the time. So let's take a look. Now, these models aren't exactly the same. The cabinet's quite different here, but the radio itself is probably identical inside. And I'm just going to scan down through this quickly, just to see the volume of stuff. But if you look over at the little slider here, you get an idea how big this document is already. There's all kinds of information here. So again, we're just looking just to scan through it. So this is the position of parts in the radio. Very helpful. That I could have used quite a bit. That's the schematic we've been looking at. I think at a glance it's exactly the same. Precautionary lead dress, I don't remember reading about that. Alignment procedure, great. Look at all the writing in here. Fantastic. Explanation of what is station setting contact. These are those little spring-loaded fixtures that press against the rotating plate. Look at how complicated they are. So this is a chart to help with doing alignment, which is coming. Adjustments for electric tuning. They call this electric tuning. They don't call it automatic. Okay, lots of instructions. Why are they showing so much reduced reproduction? I don't know why they put this in here, but they did. Insist on genuine factory tested parts. Factories in China now. Electric tuning mechanism. It lists all these radios. There it is, a kg. No, I've got a 911 kg, and almost never find this exact number. Let me look again. I'm not reading it wrong. 911 kg. That's for sure what it says. So I guess the idea with K, look at 910 kg, 911K, where's the G? Maybe there's just, comma, one more. This is, here's where the string goes around the, these are the gears. Engaging arm. With petroleum jelly. Like machine oil. Vertically mounted motors only. Or motors in vertical position. Lots of talk. Okay. Lots more talk. Is this for a different one? Adjustment of selector disc. Oh my gosh, there's an awful lot in here too. Armchair control unit, which we don't have. Modified electric tuning. Friction clutch type. There's more than one system in these radios. Yikes. Another schematic. Another parts. Why do we have another schematic? 911K. What was the other one? What's all this? Electric tuning method. More instructions. Huh. 911K. I've got the KG here. Parts list. More alignment procedure information. And I'm at the end. John Ryder. What is this document? That says Ryder. Ryder. Is it all from Ryder? Excuse me. Looks like it. Ooh. Nostalgia here. Well, I'm not sure what they've done here. They've combined a couple different documents together, so that's why they're a little bit repetitive. But you get an idea of how much information is in here, an awful lot. And we're going to go right to the parts layout diagram here. Now, this is the first one, I think. 911K. Okay, and so the parts I'm looking at right now, I will point to them in here. First, where's the volume control? Here's the volume control. And we should find a part right in this area. Motor. Okay, so it's this capacitor here, and what's happening is I'm looking at it with such, I'm looking at it on such an angle that this looks to be up here compared to this. I'm just being fooled. So C19 is one of the ones we're going after. Then there's another one down this way. This would probably C6. There's a cat walking on my keyboard. Okay, well this is working out. C19 and C6. What do we know about those? Why they don't bother showing the leads? They show one lead. Well, that was my cat just slapping the microphone in case you heard a big whoomp. Okay, let me just stop for a sec here. Okay, the two capacitors. This guy and this guy. And I've got the numbers. Let's see if I can figure out what it is they're doing. In the meantime, my cat can take care of it. It's working on the clip lead there. They like the clip leads. Okay, let's look for C19. I already know where it is. It's right here. C19. So what's happening here is the radio signal's coming along, going through this transformer, heading into this tube where it's being rectified. Just a diode. The rectified result is can be found between here and the ground. There's a voltage divider here and a tap coming off it. This is where they're taking the audio out. It's passing through this capacitor, so all audio passes through this capacitor. They're using a shielded wire at this point because the radio is very sensitive audio wise. Whatever signals are in here are going to be amplified a lot. or the signals that are in here are weak and susceptible to interference from just noise. Okay, so this would be easy to find, I think. And the other one was C6, and I found that way over here. By the way, the numbering of parts on these schematics follows a couple different patterns, but one of them is top left to bottom right. So the numbers get bigger as you go down like this. There's different patterns that are used, but that's looks like how these ones were numbered. So 6 is over here, higher numbers over there, of course. 6, look what it's doing now. It's going to ground, signal ground at the bottom of a coil. That's a pretty important capacitor. It's a large one too, another 0.1. Really? 0.1. This one's a 0.005. Okay, I'm going to change. I'm going to do one of these. Maybe this one first. And the problem here is the radio works well, so how much better can it work? I don't know. Well, considering time though, okay, stop talking and start doing. Okay, I've got the capacitor here. Let's give it a test. Considering how well the radio is working, you can't imagine there's going to be really terrible capacitors left in it. So this one is on a B+ line, the bottom of a primary coil, providing the signal ground for the signal in the coil, so the signal doesn't carry on and get into other parts of the radio. Here we go. Okay, you can't, what's going on here? You can't quite see the pi here. Maybe this is too high. Nope. Well, okay. You can kind of see it there. Here we go. Okay, so it's opening. It's definitely charging up. It didn't open all the way though. I'm sure at 150 it's just not going to open. Yeah. So the lapidated capacitor, but not open circuit, not shorted. Okay. I've already put the replacement in there. You can see it in there. This guy here. I'll go after this one. Because of my time constraints this morning, I'm not going to test the radio until after. Let me do this one too. Wow, it's really tight. Clip lead is so I can remember where it came from. Because I'm going to be cutting this one right off flush with the okay, let's see. 0.005, just like it shows on the schematic. We will give it the test here. Now this is the one that's conveying RF from the antenna, transformers and that to the grid. So all the antenna signal goes through this capacitor. So it should be a good one. Leaky? I don't know if that would be that important. I don't know. Okay, there we go. Once again, I'll try to shade this thing so you can see it better. Maybe it's the new camera, it's just seeing things a little differently. Okay, fire on. Open right up, and you can see the charge take place. 150. It's a good capacitor. Maybe it's good because it's in a position where it's not sustaining a steady DC voltage or any kind of. It's not working hard. Let's put it that way. Don't know if that would really matter. What's probably more likely in the age of these capacitors is, were they in part of the radio that got warm? That's probably more related to their life than anything. 0.005 going in, and then we'll give the radio a test here. There's the dead soldiers on the battlefield there. That's how many we've done so far. Not many left in there now. Okay, we're going to give the radio a test, and I realize I don't have the antenna switched on down here, so I'm going to go and do that, and we're going to give the radio a chance to show off. I was just connecting the antenna here, and I thought maybe now's the time to take a closer look at this. This is broken here. You can see the break on this side. The rest of it's sitting right here, there. But that's not the rest of it. There's a whole section missing. There's another. It should be 4 screws across here, and there's only 3. There's a capacitor hanging here, not connected to anything. So I just want to take a look at the schematic and see if we can just kind of figure out what that really should be. Okay, so we'll zoom in on the antenna area here. There's the 4 terminals. The ones that are present, the one I'm connecting to right now is A2. A3 terminal is there, but there's no wire connected to it. So if we look at A3, where's this capacitor? This is probably the capacitor here. Oh my gosh! If this capacitor, I think that capacitor needs to be connected to make this thing work well. At least in certain bands. If this is the one that's disconnected. There's a trimmer sitting right here. Where's that happening? So I want to look at this A1, A2. This is almost certainly intended for broadcast radio. And I'm hooking my antenna to A2. So that's really kind of dumb. Let's see, if you hook it up to A2, you're going to energize part of this coil, I guess. Oops, provided this capacitor is connected. Yeah, we got to look into this a little bit closer. And make sure that, although the radio appears to be working well, it may be underperforming because of this stuff. So let's figure this out. I got time this morning to figure this out. So let's look at that capacitor here. Let me flip over. Okay. What's that sound? Man. I was setting the speaker down on the toothbrush bristles there. Okay. Scared me. Anyway, so we have a wire off. Almost certainly goes right here. We have this capacitor in the clear, the grounded. So one side of this capacitor is going to this terminal marked G for ground. Is it really grounded? Is there? Well, it's probably grounded by virtue of the this, which is loose on a rivet. Is that really how they've done it? No, they did not do it that way. There is. Wait a minute. Let's take a look at that with a closer camera here. A closer up camera. Here it is, way over here. This may have focus problems. Let's see what happens. Well, so there's the rivet, and we want to look around the back of this and try to figure out what is going on. I'm going to have a hard time getting this to focus. It's going to focus on background stuff. Okay, for me to use this camera, I must take control of the focus. So just hang on 1 second here. Okay, I have taken control. Bring it up about like that. There. Now it's not going to change. So I'm trying to get a good view behind this screw here with the camera. It's not going to work. Okay, we're going to do another thing. I'm going to use a mirror. Oh, this isn't going to work. I'm just going to use my eye in this mirror here. I will look myself. And what I see is, yeah, there is a second lead going down. Interesting enough, There's a bare, whoops, sorry about that. Kind of left you looking in the fog there. There is a lead. You can barely see it coming down from the from this terminal. A bare wire. It disappears under the cabinet. Where's it go? Goes right in with that. The bare wire runs along the inside of the cabinet to about here, and then is soldered to a terminal. So they've made sure that this is well grounded here. That's what they've done. Not depending upon a rivet. Any of these grounds that depend upon rivets, they end up like this. Especially, you know, this is something that people work with a screwdriver on that. They're gonna move this. So you would never want to rely on a riveted ground. There are problems in these radios with riveted ground points. So not this one. Okay, so we think this wire should go there. That would be the A3. So this will be the short wave. So we don't want to worry about this one right here. We're just going to move it over here. What we want to figure out is what to do with this. What do we do with that? I didn't quite figure that out. Let's look back at the schematic again here. So the grounded part is grounded. So this connection's here. It's this connection that's missing, and it would just be tied. Well, look at the A3 wire and see where it goes. How do you make a capacitor? Oh, when they broke, who knows what happened to this radio, but it looks like when this terminal block on the back was broken, terminal strip, this was disconnected at that point. So it looks like it also speak properly here, Jim. It also, if you use a loop antenna, then you energize this coil. And this connection probably down here, it doesn't mean anything. You're energizing this coil and it's transferring its power to this coil or one of these. If you go to use the shortwave antenna, you're becoming, I don't know what to say about this now. This is, I was imagining the antenna feeding in up here, and then the antenna signal going through the coil and reaching ground. That's not quite what's happening here. See, they've also put a center tap on the coil here and brought it down. I don't know what they're doing. What are they doing? The real question is not what they're doing. What am I supposed to do? That's the real question. Follow this wire, see where it goes. This capacitor probably connected to the back of the terminal here. That's probably how they did it. And this wire probably travels right to this transformer if we can find it. Okay, I got it. Let's do it. Just leave the schematic on my own screen here so I can see it. So the thinking is this wire it goes into a bundle. This wire does not go into a bundle. It is traveling along the upper ridge of the radio here. It's twisted around a couple other wires, and now it's coming way to the front. Oh my gosh, where's it going? It's going all across the top, all down here, then poking through a hole down in this area and coming in and going straight to this coil here. That's it. So that's where that capacitor should be connected. It should be. What are we going to do here? We're going to have to restore this somehow. Yeah, I'm gonna have to restore this properly. So we're gonna just use the AM side of things. The AM side of things. We should be connecting to A1. Well, wait a minute. There's still more to the story because there's a whole terminal missing in here. It's definitely missing. Is it? Can this just fit? No, you can even see where the screw once was. Right here, right there. where the screw once was. The screw is gone. What happened to the wire? There should be a wire hanging here too. Oh my gosh, I don't see it. Somebody stole the A1 wire and clip. The whole thing's gone. Where could it go? So they're supposed to be traveling together. The A2 and the A1. Well, it's got to be this. It's got to be this then, because here they are traveling together. So I'm wrong. Oh, here's another wire. Okay. That's probably the short wave. This is probably from the back here. This actually sits this way, and this is a shorter wire. Yeah, that makes sense. It all makes sense. So this is the, well, hang on a second. Now I can, so this is a short wave, and this is, yeah, this is the one I want to make a loop connection to. This is, so I have a type of antenna that the antenna I'm using, you can connect to this as if it's a loop, and it will probably help out. Now, short wave, loop, antenna, loop antenna. What am I talking about? Okay, I'm talking about an antenna something like this. Like this is a loop antenna. The loop a wire. This particular one's tuned, and this would drive this radio pretty well. But I have something better. I have an outdoor antenna. It's not a loop, but if I hook it up as if it was, I think we'll get better performance out of this radio. Let's find out. Is he full of crap? Does he know what he's talking about? Just a pile of bull coming out of the guy's mouth. Well, we'll go with no antenna, broadcast band. Okay, broadcast band. Volume down. Switch is off. Plug is in. Dim bulbs on. Here we go. Earlier I said something about taking the fuse out for the motor, and then I did not do it and proceeded to work along on this radio quite a distance before I realized, oh my god, I never did pull the fuse out. It's out now. Shame on me. We'll get back to that motor once the radio is finished. Then we'll go back to trying to get the motor to work properly. Okay, give it the full Monty here. Today's voltage is a fresh 106 volts. I think go just a touch higher. Okay. No antenna. Broadcast band, no antenna. Just still has that weird noise thing happening at one end of the band. That stuff. Of course, we're hearing nothing. No antenna. Okay, so now we'll start putting an antenna on. First, we'll put it on the same way we've had it before. If I'm right, this should sound exactly the same. Louder. I'm not right. What about this one? So these two sound the same. This one sounds a lot louder. That doesn't add up. It did not add up. Okay, well, if these are the loop, what do I do with the ground here? I haven't done anything with it. How to experiment here? So we'll hook it up as if it's a loop. Who do we put on the ground? We'll put the ground on the quieter terminal. Get on there. Ooh. Turns out I'm a great antenna.
Last month, the city held a festival and event summit, committing $2.1 million.
This is probably how the antenna is supposed to be connected for broadcast. If I've got my act together here.
Seeking approval of a $30 million deal is signed with Canadian Tire. If approved, Canadian Tire will buy the rights to Hudson's Bay's intellectual property, including its name.
The oldest incorporated company in the world was a company called Hudson's Bay. It's a big deal here in Canada. The hundreds of year history of operating here in Canada. Its last version, like its early version, were fur trading outposts, and the last version were great big department stores in Canada, as you might imagine, selling everything. And they went bankrupt then. American equity firm bought them, and now they are taking them all. Bought them a few years ago and tried to operate it. I don't want to suggest they bought it to kill it, but that's what's happened. So the oldest incorporated company in the world going away in another few days.
Of course, Edmonton almost came back from 3-0 down last year until the Panthers took Game 7 in their barn. The changes for Edmonton, they will have home ice advantage this time, and there's a definite sense.
So when I tune the radio, instead of getting a nice peak like that, I'm getting some funny thing.
It's like to be in the Stanley Cup final. We know what to expect.
Let's see.
In Montreal has essentially banned.
You can see how wide the stations are, if you like. They're running into each other.
They're also disciplined enough where I don't think that they're going to lose.
No, I think I've just gone to the. I've turned it the wrong way. So let's go this way. Working beautiful though. This is picking out the stations and it's ignoring all the noise. How does it do this? Oh, there's a little bit of noise there. But. So I think this is Hamilton. And this is the French station, yeah. So that's coming from Hamilton. Community radio there. Oh, it's picking up really weak stations. Again, it has a lot to do with the antenna, but having the proper connection here, I'm sure, is helping. Let's experiment. We'll tune in the weak guy here. It's American station. They're talking about Republicans. Not very good this way. So we put the live one here. And the ground over here. About the same, isn't it? That's a weak station, Jeff. Not bad. That's not bad at all. So those sounds, I think, are interfering sounds being transmitted. It's not the radio itself. It's picking it up. So go this way. And there's this strange stuff here. There's a station in the middle of it. Oh, this radio's working really well. We're reaching the end of the road here. The string is doubling over itself.
Has laid out.
Why did it do that? Okay, another problem just to take a peek at and then we're done. This is something to be very much aware of here. The string should be just nice and smooth from one side to the other. Higher. Let me get it steady here and don't get a shock off it. Here we go. Now you can kind of see how the string right there got over top of itself. There, that's better.
Here, Ontario.
Zero? How did
We had an earlier problem.
You know, it should be sliding to the bottom of the valley all the time. That's what it's doing right now. Oh,
Since October.
Just a sec. There, see it slide back? So it worked perfect that time. Just 1 second here.
There's a new permission for homophobia and for transphobia. The whole, and I'm using air quotes here, anti-woke movement, the move away from diversity, equity, inclusion. So I think, and this is me being maybe a bit cynical, but I think the big corporations are saying, well, this isn't necessarily the bandwagon I want to get on now, and I'm going to step off it because it's not the cash cow right now that it was in the past. So I think it's unfortunate, John, because...
Okay, enough of that. Radio is working really, really well. And should we just take a peek at the shortwave? It's not worth doing right now. There's because of the way the sun's activity is such that shortwave's been knocked out, and not even going to check. Wrong time of day anyway. I'm pretty sure there will be nothing there. So, okay, that's great. So what do we got left? So we've still got some more of these old capacitors. 1, 2, 3. I bet you there's another 1 or 2 up in here, and to get out. But at this point, the radio's working really well. Fantastic. So have a great day. I'm on my way to where are we going? Huntsville. Going to Huntsville today. See ya.